Why polar regions are the best locations to see aurora? The polar regions, including the Arctic Circle in the Northern Hemisphere and the Antarctic Circle in the Southern Hemisphere, are usually considered the best places to observe the aurora. This video will provide a simple explanation for this fact. The Sun continuously emits a stream of charged particles known as the solar wind. This solar wind consists primarily of electrons and protons that are ejected from the Sun's outer atmosphere, known as the corona, due to the Sun's high temperature and intense magnetic activity. When the solar wind reaches the Earth, it encounters the Earth's magnetic field, also known as the magnetosphere. The Earth's magnetic field is generated by the movement of molten iron within the planet's outer core and extends far into space, forming a protective barrier around the Earth. As the charged particles from the solar wind approach the Earth, they become trapped and guided by the Earth's magnetic field. The Earth's magnetic field lines converge near the magnetic poles, creating regions of concentrated magnetic force known as the polar cusps. As the charged particles are guided along the Earth's magnetic field lines toward the polar regions, they gain energy and accelerate to high speeds. When these energetic particles collide with atoms and molecules in the Earth's upper atmosphere, primarily oxygen and nitrogen, they transfer their energy to the atmospheric gases. The energy transferred from the charged particles to the atmospheric gases causes the atoms and molecules in the atmosphere to become excited. In the process of de-excitation, these excited atoms and molecules release energy in the form of light. The characteristic colors of the aurora, such as green, red, and purple, are determined by the specific gases involved and the altitude at which the collisions occur. As a result, the aurora tends to be most intense and frequent near the Earth's magnetic poles, making the polar regions prime locations for observation. The aurora tends to form ovals or rings around the Earth's magnetic poles, known as the auroral zones. These zones are centered on the magnetic poles but can extend southward or northward depending on geomagnetic activity. Observers located within or near these zones have the best chances of seeing the aurora, with activity typically increasing in intensity closer to the poles. In polar regions, during the winter months, the polar regions experience long periods of darkness, especially within the Arctic and Antarctic circles. This extended period of nighttime provides ample opportunities for observing the aurora without interference from sunlight. Additionally, the absence of daylight reduces light pollution, enhancing the visibility of the aurora against the dark sky. Also, the polar regions are sparsely populated and have minimal artificial light sources compared to more densely populated areas. As a result, there is less light pollution to obscure the faint glow of the aurora, allowing for clearer and more vivid observations. Moreover, in some polar regions, such as parts of northern Scandinavia and Canada, the combination of cold, dry air and prevailing wind patterns can result in relatively clear skies, especially during the winter months. Clear skies are essential for aurora viewing since clouds can obstruct the view of the aurora. Overall, the unique combination of magnetic field interactions, darkness and minimal light pollution makes the polar regions the optimal locations for observing the aurora. Thanks for watching. If you liked the video, please hit the like button or subscribe button for more interesting topics.